So the next definition we have is frame section. And frame section is what I think of it as is from high school drafting, actually, where you had your elevation view, your plan view, and then your right side view. And a frame section is as if we took a piece of jam stock or header or mullion or sill and we chopped it on the miter saw or the wet horizontal bandsaw, whatever you're using to cut the material. And you took that end and you looked at it right at the end. And the SDI definition actually refers to C-frame profile. And that makes a lot of sense in terms of it being a frame profile because, as I have said in the past, think of the profile as what always comes to mind for me is a really old stamp where there's the profile of someone's head on the stamp. That's like as if you're taking an imaginary line and cutting it right down through the material and then looking at the end of it. So a frame section is that. And frame section, frame profile, the entries for SDI glossary definitions when it comes to the components of a frame, all of this really is looking at the same components of a frame and just using as the keystone a particular action definition, frame section, frame profile, etc. Well, let's switch to the screen view and we'll take a look at the different components of these definitions and then we'll just focus in on frame section.
If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video.
Okay, so frame section, crosscut of a frame member, see frame profile. Okay, so again, crosscut, again, just cutting the material here and then looking at the end of it. Frame face, frame elements is the term I was thinking of earlier. Frame member, frame profile, frame products, frame section, all comes into play here. So let's take a look at what's being referred to. The frame profile, which is why they refer to it, does give us the idea of cutting something and doing a right side view on it. This is what the frame section looks like. This is what the dimensional properties are of your frame member, whether it be a header or a jam or a mullion or a sill. The frame section shows me exactly the profile of the frame that you want in all aspects, meaning obviously the first thing is going to be the profile of the frame. Is it the typical double rabbet or is it something else? Is it single rabbet, cased opening, double egress? Okay, fine. Then it's going to fill in all of the dimensional properties that are necessary to you figuring what's required on the job. And namely, that's going to be jam depth and throat opening. Those would be real. Let's just scroll up to the frame elements definition. And they don't have jam depth here. They should, because, well, this is frame elements. So jam depth isn't necessarily an element of a frame. It's just the depth of the frame. Depth is from here to here. So you're looking at the frame section, and probably the first thing you're looking for is the jam depth. And then what is the throat opening? That's probably important as well. Regardless of it being a masonry frame or a drywall frame, I like to think of it as I want to know both. It's not enough to necessarily know that the jam depth is 5 3/4 and it's a masonry frame going to be put in with corrugated T-anchors onto an exterior masonry wall. I really want to know all about the frame because there might be some sort of an odd condition that is in conflict with some other information. For instance, I might see the placement of a 5 3/4 jam inside of a much thicker wall and take note of where the T-anchors are going to fall into a combination of face brick and CMU or block, and call that out to the customer and ask if the placement of the corrugated straps is agreeable for the job and the requirements and if some sort of a change needs to be made. So I like to incorporate what is the jam depth, what is the throat opening, and where in the overall wall thickness is the frame positioned in. So when I think of frame section, I am immediately thinking of jam depth. Okay. Then when you're figuring a job, you need to make sure that all of the other frame elements are standard. And if they are, fine. If they're not, then you make adjustments. So in our frame section, see frame profile, is the face the typical 2-inch, or is it something else? Is it a double rabbet? And if it's double rabbet, is it equal rabbet or unequal rabbet? That's really important, at least as thinking about its importance of providing the job what the job calls out. It may be unimportant, period, ultimately, whether it's equal or unequal rabbet, but you'd probably want to supply the frame that the job is calling out for or drawing. And if you're going to supply something other, it's very common to see equal rabbet frames drawn, but my manufacturer's standard is unequal rabbet. I'm probably going to note that somewhere. When I do, and I would admit that my approach is slightly unorthodox in the sense that there will be in a set of submittals that I might make, and I don't make them often, but they are a very important component of the approval process because it's part of making sure that things get to the job site correct, even though they can still show up incorrect. But it's your time to declare, this is how I want to see this material organized and installed. And I would absolutely put a note at the end stating that the drawings are scaling out as equal rabbet, but I would be providing unequal rabbet. And at least it's my way of being able to say to the customer, hey, I did mention that, because my manufacturer either doesn't do that, or there's a substantial upcharge that can't be justified to the owner, whatever it might be. But it relieves me of responsibility, but I do note it and call it out. And I will actually call out every single detail without getting into minutia, but I really want to give the customer the benefit of my, let's just assume, greater experience on the subject matter. Hey, you asked for this, but this would be better. Why are you doing this? This would be better, or this conflicts with this, etc. And I literally, at the end of my door schedule, my vertical listing of door and frame, and then my vertical listing of hardware sets at the very end, the last page is literally called notes. And so you're looking for jam depth, you're looking for throat opening, you're looking for other dimensions that may or may not be your manufacturer's standard. Face, that's a big one. I don't think you really need to worry about the projection of the stop, because that's 5/8. There may be a requirement where it's different, but it won't be smaller. You are probably going to want to be sure that the masonry frames don't have backbend returns, which would complicate your anchor approach, and etc. So when we're looking at frame section, you're focusing in on what does this thing really look like in a cross section, whether it be a jam section or a head section. Let's fire up a technical manual. I haven't opened this company's manual in a little while, and I do like their tech manual because it's well laid out. They've got a really straightforward approach to what their jam sections look like. And in some hollow metal manufacturers, you're going to have, all their common jam depths listed. We'll pull up the Seco catalog in a moment. Now, when it comes to double egress, the reason I parked on double egress is you're going to want to be sure of what you are supplying on double egress compared to what's drawn, because you can have two different headers on double egress. And I find that this stepped header is the one that I would end up using, even though it's more work to use. It does end up matching, I think, a little bit better in terms of what the job looks like. So if you're doing something different than what they've drawn, you might want to call it out. You don't want to get a dozen double egress frames set in walls, and then someone's got a problem with the fact that you used the standard head frame section profile and not the optional. It's needless to be super concerned, but it's not. The way I look at it is that it's not my money. I'm not building the building. Yeah, mullion is going to be here. Just obviously a cross section of of what the mullion looks like. And these technical manuals, this one does a really good job because I think it applies much more to a shop that's going to be making the material. It shows you how the two pieces are put together. This all has to be made on a press brake. So you've got two pieces that literally slide together, and then your job is to weld them. You get inside the throat of the frame and you weld them together. This manual from this company, which I don't think I've bought, I'm quite sure I've never bought anything from them, but I do like it because it's spread out. It's easy to read. We've stopped on frame sections of a hollow metal pocket frame. So this is interesting, where you can see exactly what this manufacturer's approach is to what a pocket frame is going to look like. If you're doing drawings, you may want to ask them if they can provide you with a DWG or a PDF of that so that you can bring it into your drawings without having to recreate it. I don't do many, obviously a top pivot prep, an intermediate pivot prep, or a pocket pivot prep. Well, no, not a pocket pivot prep. This is going to be for an intermediate pivot. That my drawings don't get. It's just not the part of the industry that we're really in to do contract-based bid work. This might be an anchor hinge. Yeah, anchor hinge reinforcement. It's a lot of fun. Anchor hinges are great. You don't sell them often. And the reason is because they don't fail, in my opinion. I've seen them in schools outside of Chicago, and those things just last decades. And when the door is closed, you really can't tell. There's a much, much bigger piece of equipment there. This would be a pocket hinge prep. So don't think of a sliding door when we use the word pocket. Think of a Harmon hinge. And if you looked up Harmon, Harmon, you'll see how that works. We try to stock a small quantity of these pocket hinges. They're neat. You see them in hospitals mostly, and I've seen them in hotels as well. Okay, so as we scroll through this tech manual from this company, DCI Hollow Metal, you get the idea. There's all these different profiles. And when you're looking at a frame section, yeah, you need to understand everything that's going on about that frame section. Looking for details that are unusual. Plus, it's not unusual to see something drawn by an architect and they've not used industry standard dimensions. The problem with that is you don't know if that's intentional or if the architect's just saying, yeah, it needs to look like this. So I would absolutely be calling that out in a note, and I would say I'd probably put in an RFI before I deviated, because it could be that the architect intended those dimensions. Most absolutely on the face dimension. If someone draws something at 1.5 inches, that's not unintentional in my experience. They literally want something to look more like aluminum, etc. So yeah, I would keep this manual in mind, especially if you're a shop, because they're showing you a lot of the preps that you're going to bump into. Yeah, okay. I had said, let's take a look at the Seco catalog. Let's do that because they may have a decent approach when it comes to showing their jams. We're going to get way into the catalog. Yeah, fabricated frames. The prior definition talks about this. Maybe too far. Yeah, beautiful. Here we go. Yeah. Okay. So this is a great frame section definition, and it's telling you what you're dealing with. Jam depth, frame depth, or jam depth. They're saying that they can do from a 4 5/8 in these frames. These are drywall frames. In these frames, they can go from 4 5/8 to 14 inch, with a throat of 3 5/8 to a throat of 13 inch. Let's go up a little bit and look at their masonry frames. Yeah. Okay. So the SQ or the SU, admittedly, forget the difference between these two. I thought one was equal rabbet and the other was unequal rabbet. That could be the difference. So great drawing of what a frame section is going to look like. Your jam depth, your throat opening, A and B. 4 5/8 through 14 inch, 18 inch increments. And that limitation is probably just because of their tooling. That doesn't mean that 14 inches is the deepest jam depth in the world. I know that I've done at least a couple of projects deeper than that. And you may not be able to use your preferred hollow metal manufacturer of choice. You might have to go to somebody else. B and C are variable. The throat and the soffit are variable because as jam depth changes, so will C. C is the variable, as is B. D and E are your rabbets, either for 1 3/4 or 1 3/8 doors. Backbend, 1/2 inch, or variable, all 3 columns. All 3 columns. Okay, yeah. Variable, variable. Your backbend. It's generally 1/2 inch, unless it's a 5 3/4 jam, then it's 7/16 because B will be 4 7/8. Backbend. If there is a backbend, yeah, they're using the term backbend. I would call this return. That's what I think everyone knows it as. If there was a backbend return, it would be like this drywall frame right here. The K is a backbend return. Stop. 5/8 up 2 1/4. Okay, let's look at that. And face, H, 1 through 5 inch. Interesting. So G and H. So G is going to be 5/8 through 1 1/4. For some reason, it could be a fire rating issue or UL labeling issue where we need a greater stop projection. But they can go 5/8 to 1 1/4. 5/8 is the standard. And then we had said G, 1 through 5 inch they can do here. 2 inch is going to be standard. It's far, far more common to see it smaller than bigger than 2 inch, except if it's a header, which would be generally 2 inch or 4 inch, unless you're doing something custom, or a sill. And that sill in a borrowed light or a side light will be 4 inch or 8 inch or whatever. We used to stock 4 inch, 8 inch, and I think I stocked 12 inch just a little bit because it's not unusual to have a sill that big. And then I for gauge, 12 through 18 gauge on this material. And it's probably shown here somewhere. Yeah, no, it's J, they're calling it J. And I said I. Oh yeah, okay, J. Yeah, that's what it is. Yeah, the thickness of the steel. 16 is standard. 14 is a really great choice. I don't really ever use 18 gauge except when it is a residential project and the client just saying, yep, 18 gauge, that's all I want. That's all I need. That's all I need. That's all I need. Very little price difference in my experience. The rule is that the door is one standard gauge increment heavier than the frame. So, pardon me, lighter is what I meant to say. So a 14 gauge frame, you're probably looking at a 16 gauge door. 12 gauge frames are usually always welded. I don't know that I've ever seen them available as a knockdown 3-piece frame. They're going to come welded from the factory. Oh yeah, sure. SU is unequal and SQ is equal rabbet frames. So I guess I would have drawn this differently and had just one letter for each of these rabbets. So it's so interesting that unequal and equal are so common that Seco literally has a different family or identifier for equal or unequal rabbet. If I was going to, in the commercial world, if I was going to choose one, it would just be equal rabbet all the time. And I've talked at length in other places about why that's the case. Okay, so the next definition is frame sill. We continue the drudgery of talking about what frame components look like. Let's move on.
Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.